So we've talked a lot about area and perimeter. So we've talked about first dimension and second dimension type problems. Now we want to talk about third dimension. So we want to start talking about volume. Now, usually when I mention volume, people think about the same thing. They think about how much liquid something can hold. When we talk about volume ourselves, we talk about half a gallon of milk, things like that. Or in this case, 1.6 ounces of orange juice. That's what we think about with volume. We think about how much measuring cups can hold when we're doing volume. Even things like teaspoons. That's why we brought us into the kitchen, because this is where we're used to dealing with volume in our natural world. Now, when we talk about volume of shapes, like cubes or rectangular prisms like this, now things get a little different. And most people know how to calculate the volume of this. Length times width times height. So that's something we're used to. However, not every volume comes in gallons. If you order mulch for your yard to plant your garden this summer, then you're going to order in cubic yards or cubic feet. And that's something a little different. You're still dealing with the volume, but you're dealing with it in terms of feet and yards. There's a reason for that, because volume really comes down to how much something can hold. Okay? So when we talk about cubic, if this is 1 cubic unit, what we're talking about is how many of these cubic units will fit inside this one larger cube. And the number of those that fit in there is the volume of that. That's one way we can think about it, how many little cubic unit blocks fit into a larger block. Another way we can think about it is how much space something takes up. It's easy to calculate the volume of this, but when we've got a solid object like this rock, or conglomerate rock, then we have to find other ways to come up with volume. Archimedes came up with the idea that if you take a liquid and put the object into the liquid, water is displaced. That amount of water that's displaced, subtracted from your original amount of water, would be the volume of the odd shape. So there's one way we can calculate volume, by figuring out the amount of space it takes up as opposed to the amount of things that go inside it. Two different concepts, same measurement. Now, I talked about volume of a cube or a rectangular prism, which is length times width times height. But things get a little trickier when I have something like this. Now, it seems like it's rectangular when I show it like that, until you realize that this is a pentagon. So here we have a pentagonal prism. So I can't do length times width times height because there's no length and width. The height, fine, no problem. But it's that length and width that gets us. So when we start talking about volumes, we need another way to think about how to make volume. So I like to take a look at volume and think about it as filling it up. So when we take our cube here and start to fill it up, we notice that the first thing that fills up is the very bottom. And I can do that again. And it just keeps filling that little by little. In fact, it fills that a little bit each time. Now, the number of times is infinitely small. But I can keep filling it, and that bottom fills up to the height of the cube. And now we've got a volume. So that's really what the volume comes down to. So we have to think about the base. And that's what we're going to be talking about in this lesson. So we're going from my kitchen here. Let's take a look at our notes. So let's take a look at our note page. So we talked about different units. We talked about 0 dimensions, which was a point. We talked about 1 dimension, which was a line. And with the line, we can measure length. We talked about 2 dimensions, which have length and width. And we talked about area. And now we're going to talk about 3 dimensions, which have length, width, and height. Now, these are just words we use. But really, it doesn't have to be length, width, and height. It could be a number of things. So the volume is one of 2 definitions. One is we could figure the volume as the number of 1 by 1 by 1 unit cubes that fit inside an object, or 2, the space an object occupies. How much space does it take up? Okay, that's the basic ideas of what volume is. Then we can take this down to how people think about volume. Like I said, most people think about volume as volume equals length times width times height. And that works great for a rectangular prism. Okay, and that's the way you first learn volume. You learned it with rectangular prisms. So a problem like this, if I want the volume of this problem, well, my length is there, width is there, and height is there. So if I do length times width times height, I'm going to get 6 times 3 times 4, and that's going to give me 6 times 3 is 18. Let's take that to the calculator. I believe that's like 72 times 3 times 4 is 72 centimeters cubed. Notice we're in cubic centimeters now because we're talking volume. Area was in square centimeters. So this is the simple problem that everybody's used to. Problem is, as we said, not every type of figure comes in these shapes. A prism that's rectangular has a base that's rectangular. The sides are either rectangles or they could be parallelograms depending on some of these weird prisms that we can see. However, we could have a pentagonal prism where my base is a pentagon, and again, all the sides are rectangles. Now, even though I keep calling it the base, it doesn't have to sit that way. If I sit this thing this way, that's still the base, even though it's sitting on a rectangle. So we have to think about that sometimes too. Here, again, sides are all rectangles, so we know it's a prism. However, the base is a triangle, so it's a triangular prism. So we can look at prisms in different shapes depending on what they have. And that brings us to our different types of prisms. Prisms can have different bases. The base of the prism is the side that is not a rectangle or parallelogram. Okay, if all the sides are rectangle or parallelogram, it doesn't matter which one you call the base. Generally, I would say I would choose the one that's not like the others. So in this one, all these sides are all the same. So I would call these ends the base. It's kind of like when we looked at this green prism here. I would call this side the base because it's one that's way different than the others. Although these two and these two, front and back, those faces are different. So really, the rectangular, it doesn't matter how your base sets up. It's when you get into other shapes. Now, if it is a cube, like we had here, where all the bases are exactly the same, all faces are the same, it makes no difference which one you call the base. In fact, when length, width, and height are all the same, I can just say edge cubed, hence where the cube comes from. Okay, so looking back at my problems here, hexagonal prism because the base is a hexagon. Triangular prism because the base is a triangle. All the other sides are rectangles. And with these, we can't use length times width times height. But look at what happens. Length and width. Well, the length and width is the area of a rectangle, which in this problem up here, the rectangle was the base. That's why I could use length times width times height. So we said what we're doing in all of these is fill the base and then a number of times. Can't spell. And that number of times is the height. So my basic formula for the volume of any prism that you want to use, the volume is capital B H. And here's the catch. The capital B stands for the area of the base. The H stands for height of prism. Okay, that's really important. In fact, I even sometimes put H sub P to remind me that's the height of the prism instead of the height of something else, like, I don't know, height of a triangle. So let's take a look at an exact type of problem. Find the volume of this prism. Notice that 3 of the sides are rectangles. So the side I want to use for my base is the side that is not a rectangle. That side is not a rectangle. That is a triangle. So I need to find its area. So this is 14. I need this last piece here. It's not 12. 12 is running that way. So I need this bottom piece here, which is going to require a little bit of Pythagorean theorem. So I'll call this small b for base of the triangle. So 9 squared plus small b squared equals 14 squared. We can go to the calculator and just calculate that really quickly. And we get that b is the square root of 115. Okay, so now that I've gotten that, I can now find the area of the base, which I've changed from A. I'm not calling it A anymore. I'm calling it capital B, because that's what I'm going to use in my formula here. You could call it A, but understand you want the area of the base. That's why I changed my lettering. So triangle, half base times height. Notice this height is not the same as that height. Okay, so when I deal with my triangle, my base was square root of 115. My height was 9. So basically I've got 9 square root of 115 over 2 is the area of the base. But again, we want the volume. So the volume is the area of the base times the height of the prism. The height of the prism will be perpendicular to the base. So there's the height of my prism, that 12. Okay, they make a right angle with each other. So 9 square root of 15 over 2 times 12. Half of 12 is 6. 6 times 9 is 54 radical. 115, I lost a number there. And there's my volume. Again, I can put centimeters cubed or cubic centimeters. So really what I need you to take a note of, find out what side your base is, find the height of the prism. Okay, let's try another problem. In fact, you try this one, see what you come up with. Think about what your base is, and then think about the height. So first question I'm going to ask you actually, what's the base? What shape is the base? So hopefully you said the shape of the base is the trapezoid. Okay, so all the other sides are rectangles. We want to look at the trapezoid here. So I need to find the area of my base. Go get the area of the base. Okay, area of the base for trapezoid. My height of my trapezoid, look like I got right angles there. So that's 4. My base is 3 and 5. So 3 and 5 is 8. So that's going to give me 16 for my base. Now go find the volume. Okay, hopefully you realize the height of the prism is the 7. So I'm going to take the area of the base times the height of the prism. So that's 16 times 7. And 16 times 7 will give me 112 cubic feet. Okay. So the cool thing is this also works for cylinders. When we look at a cylinder, we don't see the rectangular sides, but the sides are still perpendicular to this. In fact, even if it's not perpendicular, it still works as long as the bases are parallel to each other. And what shape are the bases of a cylinder? Circles. So it still works the same way. If you were to fill this up, it's going to fill the bottom circle first and then just start filling those circles all the way up. So we can use the same idea of area to base times the height. So when we look at that, if I say, hey, the volume is area to base times the height, well, it also adds us a little bit different, because this time I could say, well, my base is a circle. So some people actually create a new formula because the area of the base of a circle is pi r squared. So this could be a volume for cylinders. If you can't remember that, remember all prisms and cylinders go back to this. Just what is the shape of the base? So when I'm looking at a problem like this one, I can say my volume is area of the base times the height, but hey, my base is pi r squared h. What's my radius? Oh, that's 5. What's my height? Well, that's 13. So basically it's 25 times 13, which gives me 325 pi, and there's no units, so we'll just leave it like that. So very simple formulas, okay? Now we said not all cylinders have to be straight up and down like we're used to dealing with. Some cylinders are at a slight angle like this, okay? This is what's known as it's a non-right cylinder. The cylinder that we dealt with in the last problem is a right cylinder because the side and the base make a right angle. But here, the side and the base do not make a right angle. But it still has a height. Okay, we might have to measure that height on the outside, but that's fine. I can still do the same thing. Volume equals pi r squared h. My radius is 5, square it, times a height of 15. So when we multiply all that together, 375 pi. And this would be cubic centimeters. Okay, so quick review. Define volume. And now describe in words the basic volume formula. Okay, so hopefully you were able to describe these words as the area of the base times the height of the prism. All right. So now that you've completed this little bit of video, what I want you to do is go do one of the quizzes, okay? I've got that connected here on the Google Classroom. You can go through that. There should be a link to it and answer those questions as best you can, okay? Tomorrow you'll come into class and we'll actually practice some problems using these, okay? Have a good time. I'll see you next class.